Good morning, students. Today we are going to start a new chapter, which is system of particles and rotational motion. In the first section, we are going to deal with the rigid body, what is meant by rigid body, and we will discuss about the center of mass. In the last few chapters, we were dealing with the motion in a straight line and motion in a plane, laws of motion, work energy. In those chapters, we were studying that the body is moving in a straight line. Either it can be in a plane or either it can be one-dimensional motion, but whatever it is, we can say the body is moving in a straight line. In this chapter, we are dealing with rotational motion of the body. So, when the body moves in a circular path, which all are the changes that are taking place? How to change the equations that we have already studied in motion in a plane, motion in a straight line, laws of motion, etc. We learned many equations there. We are going to modify that equations, and we are going to apply that in rotational dynamics. So, let us see what is meant by rigid body. Rigid body is a body having perfectly definite and unchanging shape. Rigid body is a body having perfectly definite and unchanging shape. The shape of the rigid body will not change even when it moves. And we know the rigid body is made up of many particles. Say for example, my pen, it is a solid rigid body. This pen consists of many particles called atoms. All those particles are in fixed proportion. All those particles are in fixed position, and the position of that particles will not change if I throw this pen up. So, the pen is going up and now it is coming down. There is no change in the shape. The shape remains same. All the particles constituting the rigid body remains same. So, we can say this as a rigid body. So, that is what I have written here. The distances between all pairs of particles of such a body do not change. So, even when the body moves, the particles will have a fixed position. Such kind of body is called a rigid body. So, I have given two examples here. Just see the first one. It is a picture of a bridge. The bridge can be taken as a rigid body, as the distance between any two particles does not change, or it is so small, even if there is a small vibration in the particles, that vibration is very small so that it can be neglected. That is what I have written here. Now, think about the second case. Here, a lemon is kept there and it is getting squeezed. So, the lemon is not a rigid body, since we can see significant change in its shape after the application of force. So, we are giving a small force and then there is a change in the shape of the lemon. That is why it is not considered as a rigid body. So, you may ask, if I apply a large force on the bridge, will it collapse? Obviously, but the force applied is very large. It can sustain with a large amount of force without collapsing. That is why we consider that as a rigid body. Lemon can be squeezed even with our hand. That is why I am not considering lemon as a rigid body. Okay. Now, types of motion of a rigid body. Rigid body has different types of motion. The first one is pure translational motion. What is meant by translational motion? Straight line. Translational motion means the body is moving in a straight line. So, in pure translational motion, at any instant of time, all particles of the body have the same velocity. All the particles constituting the body will have the same velocity and they travel in the same direction. You can see a bullet is fired from a gun. So as the bullet is moving, the particles constituting the bullet is also moving in the same straight line. So this is purely translational motion. You have to take down the notes from the slides itself. Now the second type. So first type is purely translational motion. Now see the second type. Second type is purely rotational motion. So I have put the figure of a rotating fan. In purely rotational motion, the rigid body is fixed at an axis. You can see here there is a fixed axis for the fan, and all the blades are rotating, and even that disc of the fan is rotating. So there is a fixed axis, and every particles of the body moves in a circle which lies in a plane perpendicular to the axis and has its center on the axis. Meaning, for a rotating fan, this is considered as the axis, the central point. All the particles are rotating about this central fixed axis, which will be the radius of the circular path of each particle. Now, the distance between those particles which are rotating will be fixed. The distance between the two particles will not change. Okay? Now the third one. If the axis is not fixed, then the body will have a translational motion and a rotational motion together. So the body will undergo a combined translational and rotational motion. See, for example, look at this figure. Here I have put the figure of a roller coaster. So you can see it is going in the curve and then it goes around. So it's moving up and down and then it takes a turn. So here moving in a curve means it is the part of circular motion, and at the same time it is moving forward also. So this is a combined effect. The roller coaster is actually, the motion is actually the combined effect of rotational and translational. Now think about a top. Top is rotating, the spinning of a top. The top is rotating in the hand. Now you can see as the top rotates, it is not steady. It will wobble like this. The central axis is fixed, but it will wobble like this. So rotation is there and some translational motion is also there. Sometimes even this needle will not be fixed. The needle will move across, means along the hand. Okay, the needle also will move on the hand. So the translational motion is also there. That is what I have told here. So if the rotation of a body about a fixed axis, if the motion of a rigid body is not fixed in some way is either a pure translation or a combination of translation and rotation. The motion of a rigid body which is pivoted or fixed in some way is rotation. If the axis is fixed, it is rotation. If the axis is not fixed, it is a combined rotation and translation. Okay? That is what you understand from this figure. Now let us see what is meant by center of mass. Listen, I am taking a body. I am taking a rigid body. Rigid body consists of many particles. Rigid body consists of many particles. The distance between the particles will not change. That is what we studied just now. When you consider the motion of a rigid body, we have to consider a point where the entire mass of the body is assumed to be concentrated. I'll give an example. See, you look at me, consider me as a rigid body, and I am made up of lot of particles. When you take my motion, when you are looking at me, imagine you are looking at me, I am just walking forward. Will you think that my head is moving forward, my leg is moving forward? Will you ever think like that? You will just think Salvin sir is walking forward. That is what you will think. You won't think like this. Okay, now Salvin sir's head is moving forward. Now Salvin sir's hand is moving forward. You won't think like that. You will think Salvin sir is moving forward. Why? You are considering me as a single body. You are not considering me as different particles constituted together. Understood? So, if that being the case, to study the motion of a rigid body, you assume all my mass. To assume my motion or to study my motion, you have to assume all my entire mass is assumed to be concentrated at one fixed point. That fixed point is called center of mass. Say for example, for me, now I am considering this point where the button is placed. I consider this point where all my mass is assumed to be concentrated, and that point is considered as my center of mass. Now when I am moving, you only have to study about this point. When this point moves, in the same way all my entire body moves in the same direction. That is the idea behind the center of mass. So if I consider a center of mass point, the particles move, all the particles will move in the same point, in the same direction as the center of mass moves. Okay. So imaginary point where the whole mass of the system can be assumed to be concentrated is called center of mass. The center of mass of a two bodies lies in a straight line. So we will see. So I am just showing you a figure. There are two bodies, M1 and M2, and I want to find their center of mass. So what I am doing is, from M1 and M2, you just draw a straight line and assume a point where the mass is concentrated. That point I have marked as C. And I will tell you one more thing. Suppose if M1 greater than M2, then this point C will be lying closer to M1. What I mean is, if M1 is greater than M2, my center of mass point will come here. The point C will come here. Suppose you imagine M2 greater than M1. M2 greater than M1. Then my center of mass will lie here. The center of mass will lie closer to M2. So if M2 is greater than M1, center of mass lies closer to M2. If M1 is greater than M2, then center of mass will lie closer to M1. And what else if M1 and M2 both of them are having same mass? The center of mass lies exactly at the center. Therefore, you see here from the origin O towards the point M1, the distance is marked as x1. Similarly, from the origin O towards the point M2, the distance is marked as x2. So the center of mass of a two particle system, this is two particle system, center of mass of two particle system can be given by the equation x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Center of mass of the two particle system is given as x is equal to m1 x1 plus m2x2 divided by m1 plus m2. Suppose if there are more bodies, then what will I do? If there are more than 2 bodies, 3 or 4, so I will write it as x is equal to m1x1 plus m2x2 plus m3x3 plus etc. divided by plus mn. If there are n system of particles, I will be just writing like this: m1x1 plus m2x2 plus m3x3 etc. plus mnxn divided by m1 plus m2 plus m3 etc. mn. Suppose if the body is moving in y axis, then what will I write? Instead of x, I will write center of mass. Center of mass as y. Y is equal to m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3 plus etc. This is how we make the position vector of the center of mass. Okay. Now, the center of mass of the particle move as if all the mass is concentrated at the center of mass and all the external force were applied to that particular point. That is what I have explained. When you consider my motion, you will think a point here and you will consider the motion of this point, and when this point moves, the entire body will also move in the same direction. So, when I think about the force applied, I will take the force applied only on that particular point. I will think that all the forces are applied on that particular point itself. That is what I have written here. Now, you just see that table. For a thin circular ring is of uniform mass distribution. So, we can say for a thin circular ring, the center of mass will be lying exactly at the center of the ring. Similarly, for a circular disc, the center of mass is lying at the center of the disc. A thin rod of length L, all these things are having uniform mass distribution. Mass is distributed uniformly throughout the body. So, a thin rod, the center of mass will be half of its length. So, I can take L by 2, that distance. And for a solid sphere, the center of mass is lying exactly at the midpoint of the sphere. If it is a triangle, where will be the center of mass lying? At the centroid of the triangle. Okay, for a triangle, center of mass will be lying at the centroid of a triangle. So, instead of treating the extended bodies as single particles, we can now treat them as system of particles. And we can obtain the translational component of their motion. Translation means straight line. So, we can study the straight line motion, and that is the motion of the center of mass. So, wherever you see COM, imagine it is center of mass of the system, by taking the mass of the whole system to be concentrated at the center of mass and all the external forces on the system to be acting at the center of mass. Okay. So, please take down that also. Okay. Thank you.